today we are going to discuss the exercise 13.3 of chapter 13th, surface area and areas in the volume. Question number 1 is a metallic sphere of radius 4.2 centimeters melted, recast into the shape of cylinder of radius 6 centimeter. Find the height of the cylinder. So before solving the exercise, I just want to tell you, whenever we change the shape of an 3D object from one to another, the volume remains the same. So radius of the metallic sphere R1 is 4.2 centimeter. Radius of the cylinder R2 is 4.2 centimeter. Height of the cylinder be h. Then according to question, volume of sphere is equal to volume of cylinder. So volume of sphere is 4 upon 3 pi R1 cube. Volume of cylinder is pi R square h. So pi R2 square h. So putting the values 4 upon 3 pi into 4.2 whole cube is equal to pi into 6 square into h. On solving, we get h is equal to 2.74 centimeter. So this is the height of the cylinder. Then moving towards the question number 2, if in the question number 2 it is given that the metallic sphere of radii 6 centimeter, 8 centimeter and 10 centimeter respectively are melted to form a single solid sphere. Yes. So find the radius of the resulting sphere. So we have to find the radius of the resulting sphere. So radius of the sphere R1 is 6 centimeter square. Radius of the second sphere R2 is 8 centimeter. Radius of third sphere R3 is 10 centimeter. Let the radius of the new sphere be R. Then according to question, the volume of three spheres is equal to the volume of new sphere. So 4 upon 3 pi we have taken common. So R1 square plus R2 square plus R3 square is equal to 4 upon 3 pi R cube, because volume, the sum of the volume of the three spheres is equal to the volume of the new sphere. So we have taken here 4 upon, so we can cancel out 4 upon 3 pi with 4 upon 3 pi. So we have here R cube is equal to 6 cube plus 8 cube plus 10 cube, that is 216 plus 512 plus 1000. So that is coming 1728. So it means R is equal to 12 centimeter. So radius of the new sphere is 12 centimeter. Now moving towards the next question, question number 3. So if we see in the question number 3, so in the question number 3 we have here a 20 meter deep well with the diameter 7 meter is dug and the earth from digging is evenly spread out to form a platform 22 meter by 14 meter. Find the height of the platform. So we have here now the radius of the well, that is R is equal to 7 upon 2 meter. Length of the platform is 22 meter. And then we have the height of the platform B capital H. Height of the well is 20 meter. Width of the platform is 40 meter. So now according to the question, the volume of the earth dug out is equal to the volume of the earth of the platform. So if we see here, the volume of the earth take out will be the volume of the cylinder here. So that is pi R square h, and the volume of the platform will be L into B into H. That is the area volume of the cuboid. So putting the values 22.7 into 7 upon 2 into 20 is equal to 22 into 14 into h. So on solving this, we are getting h is equal to 2.5 meter. That is height of the platform is 2.5 meter. Then the question number 4, it is given that a well of a diameter 3 meters dug 14 meter deep. The earth taken out has been spread evenly all around it in a shape of a circular ring of width 4 meter to form embankment. Find the height of the embankment. Okay. So looking at this solution, understanding of the figure is more important. So just look here. So the radius of the well R is 3 upon 2 meter, depth of the well H1 is 14 meter and width of the embankment is 4 meter, and the width of the embankment is 4 meter. The embankment is in a form of a hollow cylinder with the internal radius R2 3 upon 2 meter. Outer radius is R1 is equal to 3 upon 2 plus 4, because since the width is given here 4, you can see the width is given here 4, so it is 11 upon 2 meter. Let the height of the embankment be h. Now, so what we are doing, we are just taking out the earth from this well and then spreading it, making it a hollow hemisphere. You can see a hollow hemisphere. Yes, the internal radius and the outer radius are given. So it means according to equation, the earth dug out from the well is equal to the volume of the embankment. So that is pi R1 square H1 is equal to pi R1 square minus R2 square into H. Putting all the values, so R1 is 3 upon 2 whole square into 14. Then R1 is 11 upon 2 whole square minus R2 square. So you can see here that the R1 is 11 upon 2 and R2 is 3 upon 2. So this is pi R2 square h. This is pi R2 square h. So on solving this, we are getting h is equals to 1.125 meters. So this is the height of the embankment, that is height of the hollow cylinder that is formed outside the at the top of the well. Then moving to the question number 5. In the question number 5, a container shaped like a right circular cylinder having a diameter 12 cm and height 15 meters full of ice cream, and the ice cream is to be filled with into the cone of height 12 cm and the diameter 6 cm, having a hemispherical shape on the top. Find the number of such cones which can be filled with the ice cream. So radius of cylinder R1 is 6 cm, height of the conical part H2 is 12 cm, radius of hemisphere R2 is 3 cm, then height of the cylinder H1 is 15 cm, radius of conical part R2 is 6/2 cm, and let the number of ice cream cones be n, then therefore the volume of cylinder will be then n into the volume of a cone plus volume of hemisphere, because if we say like the ice cream, so ice cream is in shape, means a cone and then a hemisphere, so volume of a cone plus volume of hemisphere. Now how many cones will be there? So let the number of cones be n. So therefore we have pi r1 square h1 is equals to n within bracket 1/3 pi r2 square h2 plus 2/3 pi r2 cube. So that will be 6 square into 15 is equals to n 1/3 into n into 12 plus 2/3 into 3 cube. So that will be, we'll get here n is equals to 10. So it means number of cones filled with the ice cream will be 10. Then in the question number 6, it is given that how many silver coins 1.75 cm diameter and thickness is 2 mm must be melted to form a cuboid of dimensions 5.5 cm into 10 cm 3.5 cm. So we can see the shape of a coin is also cylindrical shape, so it means volume of the cylinder will be pi r square h. So here the thickness will be its height, so it is given as 2 mm, so this will be converted into centimeter, that will 0.2, and the diameter is here 1.75, so radius will be 1.75/2. Now this has to be melted into a cuboid, so it means the volume of n number of coins is equal to the volume of the cylinder. So radius of the silver coin is 0.875 centimeter, height is 0.2 centimeter, length of cuboid is 5.5 centimeter, breadth of cuboid is 10 centimeter, height of cuboid is 3.5 centimeter. So let the number of coins be n. Therefore n into volume of one silver is equal to volume of cuboid. So we have here n into pi r square h1 is equal to L into B into H. So we have here n is equals to, just cross multiplication, 22.7. First we are putting the values, then we'll cross multiply, so we'll get here on solving it L is equals to 400. It means number of coins are 400. So 400 silver coins are required to make a cuboid with the given dimension. Now moving towards the question number 7. So in the question number 7, that is given a cylindrical bucket 32 centimeter height with a radius of base 18 centimeters filled with the sand. This bucket is emptied on the ground and a conical heap of sand is formed. If the height of the conical heap is 24 centimeter, find the radius and the slant height of the heap. So dimensions of the cylinder are given, so that is the bucket is given, radius is r1, that is 18/29 centimeter, height of the conical heap h2 is 24 centimeter, then height of bucket h1 is 32 centimeter. Okay, fine. Moving towards the next page. So now we can see here, and then it has been converted into a, we are converted this into a cone. So let the radius of the conical heap be r2. Now therefore the volume of the sand in the bucket is equal to the volume of conical heap. So we have pi r1 square h1 is equal to 1/3 pi r2 square h2. So we have here r2 square we have to find, means actually r2 we have to find. So we'll write here r2 square is equal to 3 into 18 into 18 32.24. So that is r2 is equal to 36 centimeter. So slant height is equal to root h square plus r square. So that is putting the values, root 36 square plus 24 square. The answer is 12 root 13 centimeter. Hence the radius of the conical heap is 36 centimeter and slant height is 12 root 13 centimeter. Now question number 8. So in the question number 8, we can just see here, question number 8. Water in a canal 6 meter wide and 1.5 meter deep is flowing with a speed of 10 km per hour. How much area will it irrigate in 30 minutes if 8 centimeter of standing water is needed? So as we can see the canal here, and this water, whatever the water is flowing at here in 30 minutes has to be irrigated, is used to irrigate a field whose height of the standing water is 8 centimeter. So width of canal is 6 meter, depth of canal is 1.5 meter, speed of water is 10 kilometer per hour, that is that will be 1000 by 60 meter per minute. Okay, so 1 kilometer is 1000, 10 kilometer will be 10,000. The volume of water in 1 minute is 1500 cubic meter. Or what we can do, since we have to find in half an hour means 30 minutes, so we can multiply this also by 1 by 2. So therefore the volume of the water in 30 minutes is 45,000 cubic meter. So we have to irrigate a field, let the area be A. As we know, when we see the field is in a rectangular shape, but when we put the water in the field, it becomes a cuboidal. So volume of cuboid is L into B into H, where L into B is area. So we can also say the volume of the cuboid is area into height. So we have here volume of water in the canal 30 minutes equals to volume of water in the field. So that is 45,000 is equals to A into 8 upon 100, because 8 is given in centimeter, so that has to be written in meter. So answer is coming as 562,500 meter square. So this is the area that can be irrigated in the 30 minutes. Then we have the next question, that is the last question. So in this, what is given? A farmer connects a pipe of the internal diameter. So we can see the pipe of the internal diameter 20 centimeter from a canal to a cylindrical tank with the height then which is 10 meter in diameter and 2 meter deep. If water flows through a pipe at a rate of 3 kilometer per hour, how much time it will take? So radius of pipe R1 is 0.1 meter, because it is given in centimeter. So 20 upon 200, because this is the diameter. So diameter means d upon 2 will be the radius. So this is 0.1 meter. Then we have the area of the cross section, that is pi R1 square, which is equals to pi into 0.1 square. The speed of water is 3 kilometer per hour. So that is 50 meter by meter per minute. Then volume of water 3 in 1 minute, so 50 into 0.01 pi, so that is 0.5 cubic meter. Volume of water flows in time t, so multiply by t, and the radius of the cylindrical tank is 5 meter, that is R2. Height of the cylindrical tank is H2, that is 2 meter. So volume is equals to here pi R2 square into H2. Now according to question, the volume of the water flows out in t minutes is equals to the volume of the cylindrical tank. So we have t into 0.5 pi is equals to pi into R2 square into H2. So we have t into 0.5 is equals to 5 square into 2, that is t is equals to 100. So hence the tank will be completely filled in 100 minutes. Okay, so in this way we have come to the end of this exercise. So thank you very much.